For problem 52, we're evaluating this figure with the different hot reservoir being transferring this water through a heat engine into a cold reservoir. And you're supposed to evaluate the first law of thermodynamics and the second law and see if the heat engines follow these laws correctly. So in order to do this, the first law of thermodynamics states that the change in thermal energy needs to be equal to the energy transferred out of that system. So we'll be using this equation. The work out is equal to that change in energy. And so if it's equal, then it will be following the first law of thermodynamics. So in the first heat system, in the first engine, it's both equal to 30 joules, so that follows the first law. In the second engine, the work put out is equal to 4 joules, but the change in energy is equal to 3 joules, so it does not follow the first law of thermodynamics. And the third engine, both are equal, so it does follow that first law. Now, the second law of thermodynamics states that the maximum possible efficiency of a heat engine must be equal to or less than the maximum possible efficiency. So the real efficiency needs to be equal to or less than the maximum efficiency. So we'll be using these two equations. For the real efficiency, we'll have the efficiency is equal to the work put out over that heat put in, and the maximum efficiency is calculated by 1 minus the cold over the hot temperature. So for the first engine, the energy or the efficiency is greater than the maximum efficiency, so it is not equal. For the second engine, they follow this law by stating that it's less than the maximum efficiency, so it does check out and follow the second law. And as well for the third engine, it does follow this second law of thermodynamics because it's less than the maximum efficiency, as shown by my work here.